Hello everyone. For this tutorial video, I'd like to derive a method for computing the arc length of a function using integrals. We first start by dividing the function into line segments, and then seeing that the function is approximated as a sum of these line segments. So we take more and more line segments, where each line segment is shorter, individually, until we get the actual length. We see with some creative rewriting the distance of each line segment is the x distance squared plus the y distance squared square root of all of that. We recall what the mean value theorem states from Calc 1, which is that function 1 minus function 2 equals derivative of arbitrary point between these two functions times point 1 minus point 2. And we condense the minuses with delta signs. So we now plug this in for the difference in y in the Pythagorean Theorem formula. We see that change in x squared is a common factor, and that change in x squared, the square root of that, is simply change in x. So we have the square root of 1 plus arbitrary derivative, all squared, times change in x outside the root. Because we stated earlier that the exact length would be an infinite sum of these line segments, it follows that the exact length would be the limit as n approaches infinity of the sum from I equals 1 to n of what we have just figured out using the Pythagorean theorem. And the limit of the infinite sum is the literal definition of the definite integral. So in conclusion, we plug in the definite integral sign and get this as our answer for the arc length. If the integral is with respect to change in y rather than change in x, we would have x expressed as a function of y, so now the derivative is change in x over change in y, rather than the original change in y over change in x. But the formula is the same otherwise. So now we can use a concrete example of determining the length of y equals ln of secant of x from 0 to pi quarters. We first take the derivative, see that the secants cancel out and we get tangent. And remember, we were asked the derivative squared in the formula, so now we have tangent squared. So now we plug this in. We get 1 plus tangent squared is secant squared, square root of secant squared. Is normally absolute value of secant of x, but since we are taking positive values only, we drop the absolute bars. So now we have the integral of secant, which we see as the ln of secant plus tangent. We plug in our values for our limits, and we get our final answer for the arc length. Now that we have figured out how to find the arc length of a function, we can figure out how to find surface area of shapes found by rotating a function around an axis in the next video, as it will involve the arc length formula. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.